Hi, welcome to Statistics 1. This is the first lecture, and the topic for this lecture is experimental research. As I mentioned in the introduction video, it's important to know as either a consumer of statistics or as someone engaged in statistical analyses, what type of research are you doing? What kinds of questions are you asking, and what kinds of questions might you ask of your data? So in this first week, we'll talk about first experimental research here in Lecture 1, and then correlational research in Lecture 2, because they have a very different feel, and they typically work with very different kinds of data. So let's, here in this first lecture, talk about experimental research. This first lecture is broken up into 3 segments, and that'll be common as we go through the course. Each lecture will be typically broken into either 2 or 3 segments, hopefully around 10 minutes each, but that'll fluctuate a bit. So in this first lecture, we have 3 segments. The first one, I'll give you just an example of experimental research in action, the polio vaccine trials. In the second segment, I'll give you another example, more recent research on working memory training. And then in the third segment, we'll talk more about this concept of randomness. You'll see an important aspect to experimental research is random selection from a population and random assignment to conditions. So let's go into this first segment. In the first half of the 20th century, there were approximately 20,000 cases of polio per year in the USA. In 1952 was a particularly bad year. There were 58,000 cases just in that one year alone. And polio was a very debilitating disease. It was very frightening. It happened among children of all backgrounds. And some years, as I noted here, 1952, were particularly bad and worrying. So in 1952, the first effective polio vaccine was developed by Dr. Jonas Salk. And how do we know, in retrospect, over 60 years later, how do we know that it was effective? Well, through experimental research, more specifically through randomized controlled experiments. And this set of studies is now known as the Salk vaccine trials. One of the greatest examples of experimental research put to use to solve a very critical problem facing modern society. And it's a really great success story of experimental research. So how did it work? Well, to do experimental research, again, go back to the introductory lecture, we need a sample and we need a population. So what was the population? At first, the population was all children in the USA. And actually, the population really is all children worldwide. But these initial studies were funded by the US government, the Salk vaccine trials. So I'll define the population as all children in the US. That's who Salk was hoping he could generalize his vaccine results to, is all children in the US. The sample, of course, he couldn't get his hands on all children in the US. So the sample initially was just 4,000 children from the state of Virginia. That turned out to be pretty promising result from that first sample. So the US government funded the research further, and they expanded the sample ultimately to include 1.8 million children from 44 of the 50 United States. So in this experiment, the independent variable, or what some people might call the treatment, is what the child actually receives. So some children received the actual live vaccine, the polio vaccine, and other children received a placebo. So they got a vaccine, but there was no live polio vaccine. It was just placebo. The dependent variable is what you measure after the treatment. So the dependent variable was you can think of this in one of two ways. One, if you look at the level of the individual child, you could think of it as a polio diagnosis. So each individual child is either going to have a polio diagnosis, so we could score that as a 1, or not be diagnosed with polio, so we score that as a 0. Or if we look at the level of a community of children, so if we look at towns or villages or states, then we could look at the rate of polio among a certain number of children. So two different ways to score this dependent variable. One of the cool things about using the Salk vaccine trial as an example to start this course is it was a double-blind experiment. And those are actually pretty rare in experimental psychology or in experimental trials in general, because it's difficult to do. What I mean by double-blind is that the experimenter didn't know if the treatment that they were giving to the child was the placebo or was the vaccine. So the person administering the actual vaccine didn't know if the child was getting the vaccine or getting the placebo. So no one on site at the time knew which one the child was getting, and the child and the parents, they didn't know if they were getting the vaccine or the placebo. The final results from several trials can be summarized here. This is the rate per 100,000. So children who were given the vaccine, 28 out of 100,000 went on to develop polio, versus the control who got a placebo, 71 out of 100,000 developed polio. So you can see almost 3 times more children who did not receive the vaccine went on to develop polio. So we can see, just looking at these numbers, that this was a success story. And sure enough, the US continued to use the Salk vaccine, and by 1994, polio had been completely eradicated from all of the Americas. So this is a great success story of how we can see experimental research put to use to solve a problem and eradicate what I call bad stuff. So to summarize this segment, the major benefit of experimental research is they allow for strong claims about causality. So why does stuff happen? So why was the polio vaccine happening? Well, there was this disease that was spreading through communities. Salk thought he had a vaccine that could prevent it, and sure enough, if he gave the vaccination to enough children, they were able to prevent the bad stuff from happening. So again, experiments allow us to make causal claims about why stuff happens. So that allows us to predict stuff, which means we can prevent bad stuff, and we can promote good stuff. So we use it in very basic terms, right? So this is an example where society saw we have a lot of bad stuff happening, we have this disease we have to eradicate, and if we can do an experiment to predict why it's happening and how we can stop it, then indeed we can stop it. And that's what the Salk vaccine trials were able to do. These strong causal claims require a lot of things. So they require what I call true independent variables. That is, a group of subjects, or in this case a group of children, come to a facility and they're randomly assigned to receive one level of a variable or another. So they were randomly assigned to receive the vaccine or the placebo. That's a true independent variable. I'll talk in the next lecture about sort of quasi-independent variables that aren't as strong as this. It requires a random and representative sample. So initially, the Salk vaccine trials only were done on children from Virginia. And maybe it only worked in that subset of children. Maybe it wouldn't generalize to the entire United States. They had to see, so they had to broaden their sample, get a more random representative sample of the entire United States to see if it really worked. Fortunately, it did. And finally, experimental research and these strong causal claims require that we don't have any confounds in the experiment. And that's almost impossible to rule out entirely. There might always be confounds. So there could have been confounds in terms of the age of the children, or again, the geographical location, or their socioeconomic status. There could have been lots of confounds in this example. Fortunately, they ruled out most of those in the research as they were doing the vaccine trials. But it's something to keep in mind as we look at experimental research. These strong causal claims require that there are no confounds lurking in the shadows. And we'll address that issue a little bit more directly in the next segment as we look at working memory training.